I'll try creating a new PIC10F200 setup thing going here. Standalone project, PIC10F200, debug header, skip. I'll pick my PIC, kit 3. Anyway, I'll pick the assembly compiler, MPASM, and I'll call my project name, okay, 10F200. It's my first project, the 5th of March 2022. Finish. File, new file, assembler, file types, assemblyfile.asm. Click next. Call it main. Finish. So hopefully I will get into discussing what this assembly code is all about. But to get right to it, I copied and pasted this from a very popular online source where somebody is showing how to do some very basic things with the PIC10F200 relating to assembly language. So everything seems to be good. The build was successful. I did a clean and build and everything looks good. The next test is to see if this uploads to the PIC kit. I'll do this live as I'm recording. Okay. So yeah, I'm getting the power message. Okay, I know how to fix that. I know there's a few different ways, but there's the recent one. PIC kit 3, power, apply. Okay.
Here it is, folks. I've lit up GP1 here. And there's GP1 on pin 4.
Alright, so I'll be as honest with you as possible. So first of all, I'm learning assembly language. I've been reading a popular textbook lately, and I thought it's about time I just get to trying some assembly code. So I went to a popular YouTube video. It's the circuit bread one, and this is some of the sample code they use in the tutorials. So I am not going to pretend like I'm some kind of expert delivering you some code I developed myself. No, that's not the case. I copied and pasted this. I am a genuine enthusiast, and I create videos because I enjoy this and because maybe it will help other people too. Chances are you know more than I do. But anyway, so what I can do, for the sake of my own learning, I'm going to try and explain some of the code. And yes, I am using reference material as well. Assembly language is made up of a few elements, labels, mnemonics, which I understand are just the instructions, opcodes and operands, comments. Question for myself later, which one of these categories does directives fall under? Maybe I can answer that below. So labels are typically used for branches or go-to commands. And there's a few special rules which maybe are syntactical rules. I won't cover that. But the labels are supposed to go in column 1. So I suppose init, loop, and end are labels. Excuse me, end is not a label, but these are labels, init and loop. Okay, so next, assembly instructions are sometimes referred to as mnemonics, because that's what they are. They're an abbreviation of a longer idea and a concept put into a mnemonic. And they're also called opcodes, as in operational codes. And they're just called instructions as well. So, like, I don't know if org and end are directives. That might be the case. I stand to be corrected. But definitely move LW, trice, BSF, and go to are mnemonics, or instructions. Okay, also there is something called an operand, and there's a better definition for it, but if I had to say a definition, it's just like a numerical value. Maybe you might call it a literal. And anyway, it's like a value that arithmetic is going to be performed on. So it's kind of like a number value. And in this code, admittedly I don't quite understand it yet, but this is an example of an operand here. This is a comment as denoted by the semicolon. So, having read about it here, I understand that the number sign or hashtag include is a directive, and it's including this PIC10F200 library. Is that what that is? And I understand a directive like this won't actually be included in the final machine code when the chip is programmed, but it just tells the program, the code as it's written, how to assemble the program. And the library includes some definitions which are specific to the PIC microcontroller, in this case the 10F200. I'm thinking this out loud and wondering whether all of the SFR registers, when they're typed below, like GPIO, will be recognized because they're part of this library, which is included by this directive here. So this sets the configuration bits. Of course, I've done this before in C language, and it seemed pretty straightforward to go to like the Windows drop-down menu and then do like the configuration bits. I'm not exactly sure if that's done the same way in assembly, leading you, the listener, to wonder whether I should be making a video on this. If you're listening, without going into explanation, it's always a good idea to turn the watchdog timer off. So I guess it's been pointed out that these configuration bits are separated by an ampersand, which I guess is the same as a logic AND. And this is as opposed to separating things with commas. So org is not a mnemonic. It's a directive, and it starts the program, and I understand that it's starting the program at this address, 0. This is in the program memory, and after reset, the program begins at this address, and this is put into the program counter, loaded into the program counter. So this is a label, and maybe it's acting, dare I say it, kind of like a comment, which shows the initialization. because there are no mnemonics or further code that makes reference to this label. Whereas here's a label, and there is actually coded instructions that relate to this label. So here is where the code really begins at move LW, which moves a literal value into the W register, and I stand to learn what this is really doing a little bit better, because I see that this is an operand, but it's like, what is that doing? This is the tilde. Was that like the toggle? I think. I shouldn't comment. I'm not 100%. So, unless otherwise specified, all numbers in assembly language are assumed to be hexadecimal, and those numbers go from 0 to 255, and I understand that's because that's the limit of how many bits you can include in a byte in binary. So I read, some assembly instructions deal with the W register, while others will just deal with a file register. So I guess by writing this value to GP1, this makes GP1 an output. It sets it as an output. Excuse me, I guess that's what this. Sorry, yeah. I think that's what this is doing. The tri-state register. So maybe the combination of these two lines. I shouldn't think out loud while I'm recording. Well, just like in C, to make something an output, I should read the comments. Okay, so this init label, we are initializing the microcontroller over the next 3 lines. These 2 lines here, these 2 lines set GP1 as an output. This line is where we set GP1 output high to light the LED. Oh, okay, well, I read in the reference material that this init label is crudely compared to the Arduino void setup, and then this here section might be comparable to the void loop, because here it sets everything up as this pin is an output and this GPIO pin is high, and then it just loops it forever. As to what's going on here in this code, as to how this complex operand works, well, there is an explanation in the reference material. As I suspected, this tilde is maybe toggling everything, kind of like a 2's complement. I don't know. Alright, so this comes from the PIC10 reference manual, but it doesn't matter because the assembly instructions are all the same. So in the literal operations category, on page 111, move LW, move literal to WReg. I don't see trice, as in the tri-state register, showing up in the mnemonic instructions. And I think I knew this already, but I'm thinking that's because the tri-state register is specific to PIC microcontrollers. But if you know better, leave a comment below. BSF is bit set F. It's in this bit-oriented file register operations. And it doesn't affect the status register, just for reference. Here's the go to instruction in the control operations. Go to address, first word, second word. I'm wondering whether this has anything to do with the number of stacks. And this doesn't affect the status register. I don't know if I read it into the video, but move LW also doesn't affect the status register. So I just conclude that there's nothing in these assembly instructions that affect the status register. Once again, I'm learning this. Thank you for watching. Have a good day.